As the international community's attention to soil pollution, fertility loss, and climate change increases, biochar has received increasing attention as an effective tool for soil improvement and ecological protection. The porous structure of biochar gives a good water retention and provides a good habitat for soil microorganisms. It absorbs organic molecules and heavy metals in the soil, reducing the bioavailability of pollutants, thereby improving plant nutrient absorption and promoting growth. In addition, biochar can neutralize acidic soil and improve soil fertility, thereby increasing crop yields in farmland. In agricultural applications, biochar not only effectively solves the problem of agricultural and forestry waste pollution, but also reduces the use of chemical fertilizers and greenhouse gas emissions, and enhances the survivability of soil microorganisms, thereby improving soil carbon storage. Biochar creates a positive feedback effect that is beneficial to the environment by stimulating plant growth and increasing crop yields, while the energy generated during the production process can also replace fossil fuels. In short, it has made significant contributions to the sustainable development of agriculture.